Introduction to the Computer Network, Operating Principle of Ethernet. What we want to introduce is the operating principle of Ethernet. What about the Internet? This is the local area network we're currently using. Most of them are Ethernet networks. Again, LAN is not just Ethernet. Now we are introducing the Ethernet. These are the devices you see now. Ethernet, in fact, is not just a twisted pair. It can use optical fiber. Let's see how it works. Please take a look at the slide. Then, Ethernet, what we just talked about. We represent Ethernet with a line. Ethernet. Then, the architecture of this line. We call it bus. Bus is the architecture of a bus bar. All equipment is connected to this bus bar. Then let's take a look. A packet was transmitting. What behavior types are the packets transmitting? One kind is one-to-all. My computer sent out this package. All computers needed to receive it. There are three kinds of transmission and reception methods. One is one-to-all, like radio. For example, when the teacher is in class, the whole class is listening. Then, this is the way of broadcasting. The other one is unicast, one-to-one. This is our most common way. Unicast is one-to-one. For example, in class, the teacher calls the students by calling the student ID of a student. Classmate number 5, please answer this question. That's the unicast. The other is group multicasting, which is one-to-many. For example, all the boys in the class. Then only male students need to listen carefully, right? Or 1 to 10. Then students from number 1 to number 10 should pay attention. This is the method of multicast. The three methods mentioned just now are ways of computers transmitting and receiving data. Let's take a look at the broadcast. We just talked about network cards. It only receives the MAC address of its destination, the same as its own MAC address of its network card. The two MAC addresses are the same. The computer takes over the packets. Then, the broadcast MAC address is FF, 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 FF. We just talked about 48 ones. Then, if a broadcast packet is sent, what about going out? Its MAC address is FF, 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 FF. A total of 48 bits are won by hexadecimal notation. And what if it's unicast? It's the MAC address of the network card of the destination. The destination MAC address is unicast. The MAC address of the destination. What if it's multicast? What is the MAC address of multicast? In fact, it is a Class D IP address. By using a formula to convert a Class D IP address to a MAC address, when will you use multicast? For example, we want to watch movies online at any time. I'm going to show a movie to many people. At the same time, they all want to receive these packets to watch movies. Then the clients will collect the MAC address of IP Class D. It's kind of like when our wireless radio is broadcasting. When the radio station is broadcasting, if the radio is tuned to the same frequency, you can get to a certain radio station. This is the concept of multicast. The operating mode of the Ethernet network, called CSMA, Carrier Sense Multiple Access, with collision detection. It's on the slide. Carrier Detection Multi-Access, Collision Detection, CSMA-CD. The operating mode of the Ethernet network is like wireless communication. Then its process is like this. When ham family is talking in the air, that is, when you use the radio to transmit data, they listen to the radio first. We use the ham family as an example. He listens first to see if anyone is speaking on the air. Generally speaking, the ham people will say, "Wait, wait." It means he can send the data. Then he began to speak. After that, they will say, "Over." But during this time, it's likely to be interference, isn't it? and then the Ham family will talk about it again. The operating mode of the Ethernet is actually somewhat similar to this. He just listened to Ethernet first. Whether packets are transmitted on cables, what if there are no packets on the network? Then this is carrier sense. There are no packets on networks. Devices can start transmitting data. But because as long as there is no data on Ethernet, all computers may send data, right? So, while a device was transmitting data, it can listen and transmit data at the same time. To make sure no other device is transmitting packets, what if there is? These two packets will collide with each other. Then we call it a collision. So after sending the materials, check for interference. And what if there is interference? It means collision. The sending end will send a jam signal. Jam is the signal of crowding to all the computers on the same segment. Everyone will hear a jam signal at the same time, and the signal tells all the computers, this packet is invalid. These two computers will be retransmitted. But it's very special that when these two computers are transmitting data, when retransmitting, they don't have a fixed time. They will stagger randomly. Stagger with random numbers to keep packets from colliding again when transmitting data. When this computer finishes transmitting data, if no collisions happen, they'll assume this packet was sent to the destination successfully. This is a very important concept. After this computer sends out the data, if there is no collision, it will assume that this packet is sent to the destination successfully. But in fact, it is very likely that the packets are lost during transmission through the network. The packets might be lost. Something interferes with the transmitting process. This computer is also supposed to send data successfully. There is a very important concept in this topic. That's a collision. We just talked about this collision. What does collision mean to Ethernet? Collision is a normal phenomenon to Ethernet. This is not an error. Most of the equipment, especially the hub equipment, what if the hub finds packets colliding? Basically, it has a light signal to indicate collision. It indicates that a collision happened. It is normal for this phenomenon to occur, so we don't have to worry about it. Then what about a healthy network or a normal network? The collision rate should be below 5%. The collision rate can be measured with instruments. If we don't have the instrument to measure it, we can simply look at the light signal. Just look at the light. This is the operating mode of the Ethernet. End of the course. Thank you for watching.